Dear students, welcome to the e-learning course 0, Basics of Finance. In session 1.1, you will get an introduction how to calculate future and present values, and you will understand the time value of money, meaning that money available at the present time is worth more than the same amount in the future. Now let's start with session 1.1, Future Values and Present Values. The learning goals of this session is that you know how to compute the future value of an amount of money, and you learn the concept of present value, which is to determine what is the current worth of a future sum of money or stream of cash flow given a specified rate of return. Computing the future value means that we ask a question like, how much will $100 be worth in 1 year? In order to answer this question, we need to know what the current interest rate will be. Assume the current interest rate R is 7%, the future value in 1 year is computed as 100 times 1.07, which yields an amount of $107. In a similar fashion, we can compute the future value of $100 in year 2. The computation is straightforward, since we only have to square the accumulation factor of 1.07 and multiply it with the $100, which yields a future value of $114.49 in year 2. Of course, we can do this for any arbitrary number of periods t, which is known as compound interest. In the previous slide, we learned how to compute the future value of an amount of money. However, we can ask the question in reverse and compute the amount we have to invest today in order to produce $114.49 at the end of the second year. This is called the present value, which means future cash flows are discounted at the discount rate, and the higher the discount rate, the lower will be the present value of the future cash flows. In general, suppose you will receive a cash flow of CT at the end of year t. The present value of this payment is CT divided by 1 plus r to the t. The term 1 divided by 1 plus r to the t is called discount factor. This implies that the present value can be computed as the discount factor times the future cash flow. Let's now make a first step how to think about to value an investment opportunity. Assume the financial manager of a firm has $700,000 in cash at her disposal. She can either pay it out to the company's shareholders or invest it in an office block which can be sold for $800,000 after 1 year. If the cash is distributed to the shareholders, they invest for themselves by taking investment opportunities in financial markets. Let's assume an investment in a safe asset yields a rate of return of 7%, while a more risky investment in the stock market yields an expected return of 12%. The returns of these alternative investment opportunities are called opportunity cost of capital. Compared to these alternatives, the return of investing in the office block, computed as profit divided by the investment amount, is 14.3%, and thus above the opportunity cost of capital in the economy. In this context, we can also compute the present value of the future cash flow. Since the sale price of $800,000 is certain, an appropriate discount rate to determine the present value is 7%. Applying the present value formula implies that the $800,000 received in 1 year have a current value of $747,664 today, which is above the $700,000 needed to build the office block. It seems that building an office block is a pretty good investment opportunity. Now let's introduce the concept of net present value, NPV for short. In simple terms, you can think of the NPV as present value minus the required investment. In the previous example, the cash flow received at the end of year 1 was $800,000. We showed by applying the present value formula that this corresponds to a present value of $147,664 today. The net present value is then simply computed as the sum of cash outflow in period 0, the investment of $700,000 to build the office block, and the discounted cash flow received in period 1. In our example, the NPV is $47,664. Note that C0, the cash outflow at time 0, is an investment and thus a negative number. So far, we assume that the cash flow in period 1 was certain. However, let's move away from this assumption and suppose that the future investment outcome is uncertain and we have to come up with a prediction of the future cash flow. In this context, we have to adjust the discount rate by incorporating the riskiness of the future investment outcome. A higher risk implies a higher expected return, ER, and means we have to use a higher discount rate. Discounting the future cash flows with the rate of return required for a stock market investment implies the present value of the investment project decreases to $14,286. In the previous example, we did only consider one future cash flow. However, it is straightforward to extend the concept of present value to multiple cash flows. For that purpose, we discount a stream of cash flows at the discount rate 1 plus R. This means the present value is equal to the cash flow in period 1 divided by 1 plus R plus the cash flow in period 2 divided by 1 plus R to the power of 2 plus the cash flow in period 3 divided by 1 plus R to the power of 3 up to period T where the cash flow is discounted by 1 plus R to the T. This formula is called the discounted cash flow or DCF formula and can be written more compactly as follows. To find the net present value of a cash flow stream, we simply have to add the initial cash outflow to the DCF formula. To illustrate how to use the DCF formula, let's assume we obtain a cash flow of $30,000 in year 1 and a cash flow of $870,000 in year 2. The initial investment or cash outflow is $700,000. Using a discount rate of 12% in the DCF formula implies that the net present value of the cash flow is $20,344. After having carefully studied session 1.1, please start with the review questions.